Hello everyone. Today we will be starting with the last session of S block elements, that is group 2. Some part of the group 2 like the physical properties or the comparative properties of group 1 and group 2 we have done in the previous session. And today we will be doing the last session for S block elements. Students are requested to drop down their names for attendance purpose. We will be starting in a while. Students are requested to drop down their names for the attendance purpose. We will be starting in a while. So first we will start with the anomalous behavior of beryllium, right? In the first group elements, we have seen the anomalous behavior of lithium. That means the first member of each group shows an anomalous behavior. And why? Let us see. So basically beryllium differs from rest of the members of its group. Why? Because it has a small atomic and ionic size. As we know that the size increases down the group. So the smallest radii, atomic radii and the ionic radii, second states that it has no vacant d orbitals. That means what? For example, beryllium, if you will take, the atomic number is 4 here, right? So the electronic configuration becomes as 1s2, 2s2. There is no d orbital, right? So because it has no vacant d orbital, while others, if you will see, for example, magnesium, it will be what? 1s2, 2s2, 2p6, then 3s2 and 3p and 3d will be vacant, right? So because magnesium and the other members of the group following magnesium down the group have vacant d orbitals. For example, magnesium have 3d and the next to it will have 4d, then 5d, then 6d and so on. So because having vacant d orbital, therefore it cannot expand its covalency. In chemical bonding we have learned already that some do not follow, right? For example, let us say we were having PCl5. So it was not following octet rule, right? Because it was the second group members, sorry, the second period members, if you will consider, the second period members do not have vacant d orbital, therefore they cannot expand their octet. The maximum bond that they can make is 4, right? Now it has a high charge density. Why it is having a high charge density? Because state, and also the size is very small size, it is having large density. Next is the hardness. So beryllium is denser and harder than other members of the family. Size is small, so volume is less, and we know density equals to mass upon volume. So volume is less, that means density will be more, as both are inversely proportional to each other. Next is the melting point, that is around 1551 Kelvin, while that of magnesium, if you will see, there is a much difference, right? It is around 1500 and this is around 900 Kelvin. Next is the ionization potential. So we know that ionization potential decreases down the group, right? So the first member of the group will have a higher ionization potential. Next is the reaction with acids. Due to lower oxidation potential of beryllium, that means it does not want to lose electron basically. It does not liberate hydrogen from acid easily. This is very important, right? Because of the low oxidation potential. What is oxidation potential? That tendency of beryllium to oxidize itself. That means tendency of beryllium to lose electron and form beryllium 2+, right? So this is very low, right? So basically it does not, because of this, it does not liberate hydrogen from acids readily. Now next is the amphoteric character of beryllium oxide and hydroxide. This is very much important. So oxide, if you will treat with acid, it will behave as a base and will form salt plus water. Again with base, if you will treat, this will behave as an acid and will form what? Na2BeO2 plus water, right? Here if you will see, with acid, beryllium hydroxide behaves as a base and will form berylate ion, that is BeOH4Cl2, and then with base it reacts like an acid and again it forms a berylate ion. Okay, so basically beryllium oxide and beryllium hydroxide both are amphoteric in nature. Is it fine now? Is the audio video fine now? Let me check from my side. Yeah. Is it buffering for all? Okay. Now next is the formation of carbides. So beryllium, when heated with carbon, it forms what? Be2C, right? So Be2C on reaction with water, it gives what? Methane. That is why it will be known as a methanide. Right? This carbide is known as what? Methanide. While other members of the group, for example, magnesium, calcium, strontium and barium, they form MC2. That means magnesium will form MgC2, calcium will form calcium carbide, strontium will form CrC2, which on reaction with water they give acetylene. That is why they are known as what? Acetylides. Okay, so beryllium is methanide while rest of the members are acetylide. Now next, already we have done the diagonal relationship. So diagonal relationship between lithium and magnesium we have discussed. Now beryllium size will be similar to that of what? Aluminium, right? And due to the similar size, basically they will have somewhat same physical properties and the chemical properties too. So let us see that what are the common properties in them. So like aluminium, beryllium is not all readily attacked by acids. Sorry. Beryllium is not readily attacked by acid because of the presence of a passive film. Already we have discussed that beryllium also forms beryllium oxide, aluminium also form Al2O3 film, right? So this film is a passive film which prevents further attack. Next is that beryllium hydroxide dissolves in excess of base to give beryllium ion. Similarly, aluminium hydroxide will also dissolve in excess base to give you what? This ion. AlOH4 negative. Okay. Next is the chlorides of both beryllium and aluminium have Cl minus bridged chloride structure in vapor phase. This is very important. If you will consider aluminium chloride, it has a structure somewhat like this, right? And BeCl2 structure we have already discussed in the previous session. It was also somewhat like this, right? In the vapor phase, they are having a bridge-like structure. Okay. Now, both the chlorides basically are Lewis acid. That means both are electron deficient. Electron deficient. AlCl3 is also electron deficient and BeCl2 is also electron deficient. And they are used as Friedel-Crafts catalyst. Now, this is important. In organic chemistry, all the properties. And group 2, for group 2, basically, you have to do the comparison of properties between group 1 and group 2. Comparison of properties between group 1 and group 2 you have to do. Okay, this is important from the examination point of view. Now we will jump on to the important compounds from group 2. First is calcium oxide or quicklime. This has been discussed in 10th class also, if you remember, right? So, how is calcium oxide or quicklime prepared? Calcium carbonate upon heating gives what? Calcium oxide plus carbon dioxide, right? But here if you see that carbon dioxide is removed as soon as it formed, right? For example, let us say that some amount of calcium carbonate decomposed to give calcium oxide plus CO2. Now, as soon as CO2 is formed, it is removed from the mixture. Why? Because this is an equilibrium reaction. This we will study in detail in equilibrium chapter also. According to Le Chatelier's principle, what happens that if you remove the product, the equilibrium will shift to that direction in which it wants to restore the equilibrium. That means it wants to reverse the change. So if I am, let us say, minimizing the amount of product, then the reaction will shift in such a direction where product will be produced more. That means the reverse will happen, right? So if I am removing CO2 here, if CO2 is being removed here, that means I am removing the product. That means the equilibrium reaction will be shifted to such a direction in which the product will be formed. That means more of calcium oxide and carbon dioxide will be produced now. So calcium oxide is a white amorphous solid. This you will learn in your class 12 that solids are of two types. One is the amorphous and second one is the crystalline. So calcium oxide is an amorphous solid. It has a high melting point of 2000 Kelvin approximately, right? And on reaction or exposure to atmosphere, it absorbs moisture and carbon dioxide. So it has a tendency to absorb moisture as well as carbon dioxide from the atmosphere. Now next is what is called as calcium oxide or quicklime reactions, right? Reactions of calcium oxide. So calcium oxide on reaction with water will give you what? Calcium hydroxide. Right? And calcium oxide on reaction with CO2, again you can see the backward reaction is there. Calcium oxide on reaction with CO2 will form what? Calcium carbonate. So this is calcium carbonate, right? Now when you add limited amount of water, that breaks the lump of lime. So basically, if you are having, let us say, quicklime, and you are having, or basically you are mixing some amount of water, that lump will break. This process is known as what? Slaking of lime. Slaking of lime. Right? So calcium oxide, because it is a metallic oxide, it is basic in nature. Because it is a metallic oxide, it is basic in nature. So it will react with acid oxides. For example, calcium oxide, metallic oxide, silicon oxide is a non-metallic oxide if you will consider. So it is a acidic oxide, and calcium oxide is a basic oxide. So they will form what? CaSiO3. Again, here if you will see, P4O10 is a acidic oxide, while calcium oxide is a basic oxide. So again they will form what? Calcium phosphate. Now next is uses. It is used for manufacturing cement. This is important, that it is used for manufacturing cement, and it is the cheapest form of alkali. Second, it is used for the manufacture of sodium carbonate, that is Na2CO3 reaction we have discussed previously. Next, it is employed in purification of sugar. This is also important. So two uses you need to remember for it, that it is used for manufacturing cement. Second one, it is used for the purification of sugar. Right? Now, if you will take a mixture of quicklime, let us say calcium oxide and sand. Sand is what? Basically SiO2 in the ratio of 1 so as to make a thick paste out of it. That paste is called what? Mortar. That paste is called what? Mortar. So calcium oxide plus SiO2 ratio, they will form what? A thick paste, that is known as what? Mortar. Now next is calcium hydroxide, which is called what? Slaked lime. Now you can get confused out of it. So calcium oxide is what? Quicklime. Calcium hydroxide is what? Slaked lime. Okay. So calcium hydroxide is prepared by adding water to quicklime. So basically calcium oxide plus water will give you what? Calcium hydroxide. Now it is a white amorphous powder which is sparingly soluble in water. Sparingly soluble in water means that it is hardly soluble in water. Okay. Now the aqueous solution of calcium hydroxide is known as what? Lime water. It is known as what? Lime water. And a suspension of slaked lime in water. Slaked lime we have already discussed, right? So that in water is known as what? Milk of lime. Milk of lime. This you need to remember the terms. What is lime water? What is milk of lime? What is slaked lime? What is quick lime? What is the reaction between quick lime and water to give slaked lime? These you need to remember. Okay, once you will read it, you will memorize this yourself only. Okay. Now, when carbon dioxide is passed through lime water, so basically calcium hydroxide plus CO2 will give you calcium carbonate, which is responsible for turning what? Lime water milky. It is responsible for turning lime water milky. Why the lime water turns milky? Because of the formation. Now, when you pass excess of carbon dioxide through calcium carbonate, it will produce what? Soluble calcium hydrogen carbonate. That means now the turbidity that was being produced, the white turbidity or the milkiness that was being produced is removed, because calcium hydrogen carbonate is soluble, right? While calcium carbonate was forming a turbid solution. Now, milk of lime, calcium hydroxide reacts with chlorine to give you what? Hypochlorite, which is known as bleaching powder. Basically, the formula of bleaching powder is very long. So, we just call it calcium chloride plus calcium oxychloride mixture is known as what? Bleaching powder. Right? The exact formula you need not remember from the examination point of view. Now, next is the use. It is used for the preparation of mortar, as we have seen previously. So what is mortar? It is basically a building material like cement we take or brick we take. So mortar is also a building material, right? It is used in whitewash, we already know, at homes also. Now third one is it is used in making glass. It is used in making glass, and it is used in bleaching powder preparation. So what is bleaching powder preparation? Basically, the use of bleaching powder is that it lightens things, right? For example, you are having, let us say, bleaching the wood pulp. So it means that you are lightening the color of the wood pulp, right? Tanning industry basically means that tanning of leather is done. Tanning of leather is done. Skinning of leather it is called. So tanning of leather is done. Now, next is calcium carbonate. So, calcium carbonate can be found in limestone, chalk, marble, right? So, the marble which we have at our homes also is calcium carbonate. The chalk that we use is calcium carbonate. Okay, so how it is prepared? Again, calcium hydroxide plus CO2 will give you calcium carbonate. Or you can use the other method, that calcium chloride on reaction with sodium carbonate will also give you what? Calcium carbonate. Okay. Now, excess of CO2. In this reaction, if you will see, if you will pass excess of CO2, this calcium carbonate will be converting into what? Calcium hydrogen carbonate. Right. So, to stop the reaction at calcium carbonate, you should avoid using excess of CO2. Now, calcium carbonate is a white fluffy powder. Here you can see as that of talc. Right. It's similar to as that of talc. So calcium carbonate, again on heating at 1200 Kelvin, it gives what? Calcium oxide plus carbon dioxide. Calcium carbonate reacts with acids such as HCl and H2SO4 to form corresponding salts plus water plus carbon dioxide. These all reactions you have done in your 10th class also. Right? So calcium carbonate plus HCl will give you what? CaCl2 plus H2O plus CO2. Then here calcium carbonate plus H2SO4, SO4 will combine with calcium and form calcium sulfate, and carbonate will evolve as CO2, and the rest hydrogen and oxygen will combine to give you what? Water. Now next is uses. So it is used in the building material, right, in the form of marble also, and in the manufacture of quicklime also. What is quicklime? Calcium oxide. It is used for the manufacture of high quality paper. It is also used as an antacid. Right. So when we are having basically acidity, we take medicines which are called as antacids. Right. So these are used in toothpaste also, chewing gum also, and it is used as a filler in cosmetics also. Now next is calcium sulfate, plaster of Paris. So what is plaster of Paris? Calcium sulfate dot half H2O. This also you have done in your 10th class if you remember. Right. So calcium sulfate dot half H2O is called what? Plaster of Paris. It is obtained when you heat gypsum, which is calcium sulfate dot 2 H2O. When you will heat it, you will get what? Calcium sulfate dot half H2O, which is known as what? Plaster of Paris. What is the temperature of heating? 393 Kelvin. 393 Kelvin. Now, if you will heat calcium sulfate dot 2 H2O, that is gypsum, above 393 Kelvin, what happens is that all of the water is removed. Now, only calcium sulfate is left, right? No water is left now. Only calcium sulfate is left, and this is known as what? The dead burnt plaster. Dead burnt plaster. That means you have removed all the water from calcium sulfate. That will give you dead burnt plaster. And if you have removed 1.5 water molecules from calcium sulfate, that will give you what? POP. That is plaster of Paris. Now, the property of POP basically that on mixing with an adequate quantity of water, it forms a hard plastic mass, right, which turns into a solid in 5 to 15 minutes. Right? People who have broken their bone must have known this. For example, this is a POP which is basically wet in water and then applied to the broken bone area, right? And after some time, it becomes hard, right? So, plaster of Paris, on settling down with water, on a minimum amount of water, it will form what? Orthorhombic form of gypsum. Now, what is orthorhombic or rhombic? This you will learn in your class 12, that is solid state chapter. Right? It is a type of a crystal system. This you will learn in solid state chapter. Okay, so plaster of Paris, on setting down with water, it will give you what? Another form of gypsum, which is known as orthorhombic form of gypsum. Now the largest use of POP is in the building industry as well as plasters, right? Here you can see this is known as what? POP, this thing, right? Next, it is used in the bone fracture or sprain area. It is also employed in dentistry, right, in ornamental work also, and in making statues or bust also. So the god and goddesses that you must be having at your home who follows Hindu religion, that are also made up of what? POP, right? On POP basically they paint different colors. The main structure is made out of POP only. Next is bleaching powder. Calcium oxychloride is known as what? Bleaching powder, right? Or it is known as also chloride of lime. So its preparation is that calcium hydroxide plus chlorine will give you what? Calcium oxychloride. Calcium oxychloride. When you dissolve in water, it will give you what? Calcium 2 plus differently, chloride minus differently, and OCl minus differently. That means each one of them will break into ions, right? With H2SO4, what happens is that it forms HClO, right, which decomposes to form HCl plus O. This single oxygen atom is known as what? Nascent oxygen. Now this oxygen can be added to different species, right? So basically, because calcium oxychloride has the ability to produce nascent oxygen which is added to the other species, that is why it is and the experimental value, because of this reaction, that calcium oxychloride forms what? Calcium chloride plus calcium chlorate, right? Because of this reaction, that some of the calcium oxychloride decomposes to calcium chloride plus calcium chlorate. That is why less amount of calcium oxychloride will be converted into chlorine. Okay. Now what are the uses? Again, because the name is only bleaching powder, that means it will be used for bleaching. It is also used as a germicide in sterilization of water, right? Germicide is what? Basically which is used to kill germs, right? It is used for making wool unshrinkable, and it is also used in the manufacture of chloroform. What is the molecular formula of chloroform? That is CHCl3. This is known as what? Chloroform. If you will write it as CHI3, that will be known as what? Iodoform. If you will write CHBr3, it will be known as what? Bromoform, and so on. Now next is cement. So cement is an important building material. It was first introduced in England in 1824 by Joseph Aspdin, right? So it is also called Portland cement. Why it is known as Portland cement? Because it resembles with the natural limestone which was quarried in the Isle of Portland, England, right? So basically it was somewhat similar to the natural limestone which was found in Portland, England. Therefore, it is also known as what? The Portland cement. Now, what is cement actually? So, cement is what? Basically, when you mix calcium oxide with other materials, such as if you will mix calcium oxide with clay, let us say, right? So, clay is containing what? Silica. So, if you will mix CO2 plus SiO, aluminum, iron, and magnesium, then you can get cement. Right? Now, what is the proportion? So, calcium oxide should be 50 to 60%, silicon oxide should be 20 to 25%, aluminium oxide should be 5 to 10%, magnesium oxide should be 2 to 3%, iron oxide or ferric oxide should be 1 to 2%, and SO3 should be 1 to 2%. Right? So, this is the composition which you do not need to learn. Only you need to learn is that calcium oxide and silicon oxide and the oxides of aluminium, iron, and magnesium makes cement. Okay. Otherwise, you can leave all the things. Only from this paragraph, you need to only memorize that calcium oxide plus silicon oxide plus oxide of aluminium, iron, and magnesium will yield you what? Cement. Right. So here are the given ratios, right, for a good quality. If you want, you can skip it also, but for additional purpose we have kept this additional knowledge, right? So the ratio of SiO2 to alumina, Al2O3, should be between 2.5 to 4, right, for a good quality cement. and the ratio of calcium oxide to the oxides of silicon and aluminium and iron should be close to 2. Right? This is only for general knowledge. If you want to skip, then you can skip that also. Now, what are the raw materials for the manufacture of cement? They are limestone and clay. So when clay and limestone are heated together strongly, they form what? Cement clinker. Cement clinker. Now this cement clinker is mixed with gypsum to form cement. Right? This you can leave. It is only for additional knowledge that Portland cement ingredients are dicalcium silicate, tricalcium silicate and tricalcium aluminate. Now next is the setting of cement. If you have observed at your homes also that if you mix cement with water, first it is a liquidy kind of mixture, and then after some time it hardens. Okay, it converts into a hard mass. So this is due to the hydration of molecules of the constituents and their rearrangement. That means the constituents which are making cement, that we have already learned, calcium oxide, silicon oxide and oxides of iron, aluminium. Right, so due to their hydration and rearrangement, this cement sets down as a hard mass. Right, so why do we add gypsum to the cement? Now this is important to slow down the process of setting of the cement. Right, so that basically what happens is that if you won't add gypsum, it will not get sufficiently hardened. Right, gypsum, what it does is that it slows down the process of setting of the cement, so that enough of time is there for cement to settle down and to get sufficiently hard. Now use, we already know that it is used for making buildings, bridges, dams, etc. Now comes the biological importance and uses. So what is the biological importance? Here if you will see that our body contains 25 gram of magnesium and 1200 gram of calcium, right? While only 5 gram of iron and 0.06 gram of copper is there, right? Now all enzymes that utilize ATP. What is ATP? Adenosine triphosphate, right? So it is an energy generator basically, right? So all enzymes that utilize ATP, they require magnesium as the cofactor. So this is the use of magnesium again. Now chlorophyll, already I think we have discussed, and if we have not discussed, I'll repeat it again, that chlorophyll is made up of what? Magnesium as the central metal, right? Magnesium is used as the central metal, right? And this ring is basically called what? A macrocyclic ring. It is known as what? A macrocyclic ring. So a cavity is there. Let us say that this is making a cavity in which magnesium is fitted, right? So this is known as macrocyclic ring, which is known as what? Chlorine ring. Chlorine ring. You can remember it as chlorophyll, chlorine ring. Okay. Now next is calcium. So 99% of body calcium is present in bones and teeth. It is also used for neuromuscular function, cell membrane integrity and blood coagulation. Now this is important, that calcium plays an important function in blood coagulation. What happens is when we have a wound, right, on our body, to stop bleeding, our platelets, or you can say that coagulation of blood happens, right, automatically, which is done automatically by our body. So some function of it is also done by calcium. Now the calcium concentration in our plasma is about 100 milligram per liter. That means 1 liter of our body plasma contains 100 milligram of calcium, right? Now this level is maintained by two hormones, that is calcitonin and parathyroid hormone. So these are the two hormones that basically maintain this concentration in our plasma. So here you can see that calcium in our body is 39%, potassium is 0.2%, sodium is 0.7%, magnesium is 0.4%, carbonate is 9.7%, phosphate is 17%, right? So total inorganic components comes out to be what? 67%. Okay. So this is the composition of bone, right? Now next, this you need not learn, only you can learn that what is the biological importance of calcium in our body. First main that comes into our mind is what? That bones and teeth are made up of calcium. Second one is blood coagulation. Third one, what are the two hormones which maintain the required concentration of calcium in our plasma is calcitonin and parathyroid. Now, if you consider kidney stones, they are because of what? Calcium oxalate. So basically they dissolve in strong acid, but in bases they remain insoluble. So due to this formation, excess of calcium is also harmful for our body. And if calcium is present in calcium oxalate form, then we generate what? Kidney stones. Now, beryllium is used in corrosion resistant alloys. What are alloys? Basically, mixture of a metal and metal, or a metal and a non-metal. Alloy of magnesium with aluminium, if you will take, it is used as a structural material. Why? Because it increases the strength, right? Magnesium and aluminium, when you make alloy of it, it has a high strength. Next is strontium carbonate. It is used for the manufacture of glass for color TV picture tubes. Color TV picture tubes have strontium carbonate in it. Next is barium sulfate. Basically, it is used to scan the X-ray of the human digestive system. Again, magnesium is present in chlorophyll. Already we have discussed, which helps in the photosynthesis. Anhydrous calcium chloride, it is hygroscopic in nature and it is used as a good drying agent. That means it is used to remove moisture or water from some compounds, right? But its limitations are that it cannot be used to dry alcohol, ammonia or amine. Alcohol, ammonia and amines are not dried up by calcium chloride. Otherwise, rest of the materials can be dried up by anhydrous calcium chloride. Now, magnesium perchlorate, it is also used as a drying agent. It is also used as a drying agent under the name of anhydrone. Anhydrone. Now, let us come to the practice questions so that we finally complete the chapter. Okay. First question is, the percentage water loss when gypsum is heated to get plaster of Paris is? What should be the answer? See, gypsum is what? Calcium sulfate dot 2H2O. And plaster of Paris is what? Calcium sulfate dot half H2O. That means change of how many water is taking place? 1.5 H2O. Right? 1.5 H2O is decreasing here. Right? So what is percentage? Percentage is change divided by original. Change divided by original into 100. So what is the change in the number of water molecules? 1.5. Then what was the original number of water molecules? 2 into 100. So this will give you what? Around 75%. Okay. So this is a numerical type question. Now, multiple correct MCQs there. That means more than one option can be correct. The temporary hardness of water is caused by which of the following compounds? Already we have done hydrogen chapter in which we have discussed the hardness of water. Tell me, who are responsible for carrying out the temporary hardness of water? More than one answer can be correct. A, B, C, D. Which among the following are responsible for temporary hardness of water? Temporary hardness of water. Anyone with the answer? Anyone with the answer? Okay, Dinesh is saying C. Okay, calcium hydrogen carbonate and magnesium bicarbonate, right? So both of them are responsible for the temporary hardness of water. And for permanent hardness, you are having what? Chlorides and sulfates, right? So B and C both are correct. Good. Now, in which of the following cases is the value of X maximum? I'll give you an hint that down the group, tendency of hydration decreases. Tendency of hydration decreases. Why? Because there is an increase in the size. Increase in the size, and we know that hydration is inversely proportional to size. So as the size increases down the group, hydration decreases. Now you tell me that which one of them will be associated with the maximum values of water. Anyone with the answer? I have given you the hint already. What should be the answer? The one that is having the smaller size amongst. Yes, Dinesh, you are very much correct with your answer because magnesium is smaller in size. So therefore, hydration of magnesium will be more, and therefore the water molecules that must be associated with magnesium will also be more. So C is the answer. Good. Now next question is, 1 mole of a substance was treated with an excess of water. That means X was treated with water, right? And a gas was produced which was readily combustible along with a solution, right? Now this solution, when treated with carbon dioxide, it produces a white turbidity that we know, or I'll give you the hint that it is of calcium carbonate, right? Now you tell me what should be the substance X. What should be the substance X? So here we know that calcium hydroxide plus CO2 will give you what? Calcium carbonate. That means here it should be what? Calcium hydroxide. And what is a flammable gas? Hydrogen gas, right? So solution is calcium hydroxide and hydrogen gas. So now what should be X? What should be X? Should it be calcium? Should it be calcium hydride? Should it be calcium hydroxide, or should it be calcium nitrate? I have given you all the hints. What should be reacting with water to give you calcium hydroxide plus hydrogen gas? Anyone with the answer? X plus water is giving you calcium hydroxide plus hydrogen gas. What should be X? So X should be calcium hydride. Calcium hydride reacts with water to give you calcium hydroxide plus a flammable gas or a combustible gas which is hydrogen. This calcium hydroxide on reaction with CO2 will give you what? Calcium carbonate, which is responsible for the white turbidity or the milkiness, as we have discussed in the session today. Now, next question is, the solubility of hydroxides of alkaline earth metals increases down the group. Why? Solubility of hydroxides of alkaline earth metals. That means that barium hydroxide is much more soluble, then strontium is less soluble, then you're having, let us say, calcium is less soluble, then magnesium least soluble. Why? How do we define solubility? I have already told you many a times that how can you define that a particular compound is soluble or not? What is the criteria? What is the criteria for a compound to be soluble? The criteria should be that hydration energy should be more than that of lattice energy. Now down the group, what should be happening? That the solubility is increasing. That means what? Either the hydration energy should increase or the lattice energy should decrease so as to increase the solubility down the group, right? So that means the decrease in lattice energy is more prominent than decrease in hydration energy, or the decrease in lattice energy is less prominent. If the decrease in lattice energy would have been less prominent, then the solubility would have decreased down the group, right? So first option is correct, that the lattice energy decrease is more prominent than the decrease in hydration energy. That means the lattice energy is more decreasing than that of the hydration energy. Let us say I am taking any arbitrary value here. Lattice energy was 50 here, hydration energy was 50 here, right? Lattice energy became 40, hydration energy became 45. Lattice energy became 35, hydration energy became 40. Lattice energy became 30 and hydration energy became 37, let us say. So at all points, what is happening? That hydration energy is more than lattice energy. So the solubility is increasing here, right? Because the lattice energy is decreasing more prominently than that of hydration energy. So the answer should be what? First. So a compound to be soluble, basically the hydration energy, the magnitude of the hydration energy should be more than that of lattice energy always. Elements which do not undergo flame test are, this we have done in the previous session. Anyone with the answer? Elements which do not undergo flame test, they do not give color on subjecting to flame. We have done this already in the previous class. You must be able to answer this. It's a direct question. Anyone with the answer? So A and B both. Anyone with the answer? A and B both do not undergo flame test. Beryllium and magnesium do not give any characteristic color to the flame test. Why? Because their ionization potential is very much high. Okay, so beryllium and magnesium do not give colors to the flame test. Next is brick red color of flame test is given by. Which one of the following elements gives brick red color to the flame test? Brick red color to the flame test. Brick red color to the flame test is calcium. So calcium gives brick red color to the flame test. So that's all for today. We are done with the S block chapter, and in the next class we will be starting with the P block chapter. For S block, you can follow NCERT and you can revise the sessions thoroughly. Right? These are more than sufficient.